And so for our speaker, we have Randal Schwartz, a well-known figure in the blogosphere and the Perl community who's recently become a Seaside enthusiast.
Thank you for that invitation, Alan, and I mean that in the larger sense, so thank you for inviting me to talk today. I think it's sort of interesting and cool that the very first Smalltalk conference I've ever been to, I'm already a keynote speaker. So that's kind of a cool thing, I think. That might be a record or something. So let me put my slides up here. Actually, before I get started on my slides, as I was coming up with the material for the presentation for today, I had erroneously figured I only had about 45 minutes for my talk, and wrote about 45 minutes worth of material, and that's what I finished yesterday. And looking back at the schedule, I realized I had 90 minutes. Now, I could just let you out early and let you all go to lunch a bit early, but instead what I decided to do is at yesterday's Seaside Birds of a Feather session, there were a surprising number of people who hadn't really gotten into Seaside yet. And I thought, well, my talk on persistence won't make a lot of sense if you don't know a lot about what Seaside is. And I also know that many of you already know plenty about what Seaside is, but are trying to inform this to the people around you to say, this is really what I'm working on, this is why I'm enthusiastic about it, and so on. So I have a presentation that I've now given about a dozen times to various places like the executive group of MySpace.com and a large microprocessor manufacturing company in Mexico. And probably my biggest performance was down at the FISLI conference, which is the annual open source conference in Brazil. I gave this talk called Seaside, Your Next Web Framework. It's only about 20 minutes when I go through it, and I leave out the parts about the actual live demo. So Alan is allowing me to present that ahead of the other talk. And if you're new to Seaside, this will sort of bring you up to date about why we think Seaside's interesting. If you're already an expert in Seaside, listen to it for ways to tell other people about how to, why you're enthusiastic about it, why you're using it, and that sort of thing. So I'm going to start with my advocacy talk. By the way, as a result of giving this talk in Brazil 2 months ago, the FISLI people, where the conference is attended by 7,500 people every year, gave me an entire 3-day Smalltalk conference next year that they'll host for us. So there will be so I'll be hitting up some of you guys to fly down to Porto Alegre, Brazil during June of 2009, because I'm going to need to fill 3 full days of programs. So if you see me running around with a notepad going, please, I need speakers, this is what I'm looking for. So there we go. So this is the slightly more advanced version of what I gave in Brazil a couple months ago, and a bunch of other places as well. So if I only had 30 seconds in an elevator to tell you why I'm excited about Seaside, it would come down to the first 4 points that I want to hit sort of at the top level. First, it's Smalltalk. And I'll go into details about why I think Smalltalk's interesting here, although in this particular room I'm preaching to the choir. Okay? It's also continuation-based. I'll explain what that means and also give you an idea of how that makes web development different in a radically interesting way. There are also various persistence and scaling solutions, which, by the way, is the second half of my talk, so I won't go too much into it during this part of the talk. And there's also a very large and growing community. Here we are. So I won't talk too much about that either. So basically, I'm just giving you the bullet points. You'll see that. Why do I like Smalltalk? Well, for me, it's very simple to learn. I can show you the entire syntax in 2 minutes or so. Very simple to do that. It's simple to learn the syntax. Takes the rest of your lifetime to learn the library. I know, it's been there before. It's also, again, I'm expanding on all these points in a few minutes. There's also very mature debugging, real good framework for unit testing, including testing during web delivery. The templating isn't a separate language, and when we get to the Seaside part of it, we'll see that we're still using Smalltalk even for that. And also, there are a number of vendor choices for implementing your result. And we have good team development tools for distributed development and so on. So let's take that first bullet, simple to learn. Why do I think that Smalltalk is simple to learn? Well, I can show you, like I said, the entire syntax in 30 minutes. Or I said 30 minutes here, I said 5 minutes, whatever, same thing. Okay? It's a matter of scaling, right? Also, because the entire syntax is easy to learn, then really the library where you want to go, but the nice thing about having these already existing libraries is that the source code's all included. So that means you can use the libraries that are already included in your Smalltalk image as a way of getting better examples of coding, or in a few cases, examples of how not to code. Okay? The other thing I like about that is that because all these classes are open, they're not locked away. There's no primitive classes in Smalltalk. I can extend anything. I can subclass from anything. I can even monkey patch anything, but that's another story. And also because it's Smalltalk, it's been around for a long time. It's mature. It's been around for 28 years or so. That means there's a lot of material to study. There's a lot of existing literature on it. And keep in mind that this talk is mostly delivered to people that are really hot on, say, Ruby on Rails, or maybe Perl development or something. So what I'm trying to do is show what's different about those descriptions from what Smalltalk is. Smalltalk also, because it's been around for a long time, has very mature debugging. And again, I'm preaching to the choir here, but the walkback stack is alive. It's not, someone put it so elegantly, you're not like doing an autopsy of a dead body on a table. Is that you, James? Yeah, there we go. Thank you, James, for that one. I really love that one. So the walkback stack being alive means that any level that I'm looking at, I got direct access. I can look at the source code, I can look at the object that's being involved, look at its instance variables, I can look at the arguments. And I can poke around with them. I can execute interactive code against those and modify that. That's not available in most other development environments, except maybe some of the other dynamic languages like Perl. But the best part about it, even Perl doesn't have this, is I can edit the source code, I can update the code, and then proceed. So instead of having to recreate my program state from the beginning, I can proceed from the middle. For those of you that have been doing Smalltalk so long, you've forgotten what it's like to work with other languages. That's not very common. Okay? They're just now catching on to that 28 years later. Maybe we might want to do that someday. Okay? But the best part about that is that when we mix that in with a web framework, we get intra-hit debugging. So when I get an exception because I've written a bad piece of code in my Seaside code, I get a walkback stack that is live. I can now go in and look and do the same thing I would do with an offline program. I can go in and examine the entire stack. I can figure out where the problem is, and I can fix it and proceed from there, fix the code, and then you're still within the same webhead. And this is pretty amazing. This is a real key point for me about why I think Seaside is different from anything else I've seen. And so I really emphasize this when I'm talking to these various groups, because this is really a key point to it. And it's the thing that gets the eyes the biggest wide opening there, too. I was on an interview with Web Dev Radio a couple weeks ago. Some of you might have caught that podcast. And I like the way James put it. You could hear the guy's jaw just drop when I was told him about this intro WebKit development. So go check that out. My blog at the end will have links to everything that I've been doing in terms of publicity. Another thing about Smalltalk that makes it interesting is that we have good unit testing. Smalltalk community practically invented extreme programming. I think probably the Java community claims some of that, but I know we're the ones that got it right, so here we go. Also, really good testing frameworks available for Smalltalk, the S-Unit framework and others, which allows us to test for things like, are the values correct, and are the exceptions being thrown properly, and so on. So we can do our traditional unit testing stuff in a really sort of organized and structured way. And this, again, encourages good programming, encourages maintainable code, allows us to do test-driven development, and so on. On top of that, there's some packages written for Seaside, what I'm familiar with is Seaside testing, that let us go even further and test the application program flow to figure out if our application's going from one page to the next properly. So we have sort of end-to-end testing already. There's also another package whose name I forgot, I didn't put it in the slides. This is JavaScript and hits it all the way from the front. I don't remember which one that is. What's the name of that? What is it? Albatross, right. So Albatross is out there. Actually, I'll add that to the slide for the next presentation. So very good stuff, good testing all the way up and down. Again, because it's Smalltalk, we learn one language to do everything. And Seaside chose to use Smalltalk as the templating language. So we're not shifting to some other sort of embedded codes or whatever to go from one thing to the next. But the syntax for Smalltalk is very simple. And if I was doing a real presentation here, I would have gone into a demo already showing the basic syntax form for Smalltalk. So I'm going to presume you've all seen Smalltalk before, or this would be a bad place for you to be right now. Okay. But anyway, the key point about Seaside is that you're essentially using traditional method calls to create your HTML. So you say HTML heading level 3 gives us a third order heading. We paint hello as the content. One of the nice things about that width there is that hello is automatically HTML escape. So I don't have to worry about a value generating appropriate less thans and greater thans messing up my day. So all this talk we hear from other frameworks having problems with cross-site scripting, already taken care of in Seaside. It already does the heavy lifting for us on that. Second one there, of course, is a paragraph. Again, the appropriate less than greater than escapes would have happened already. Third one shows that I can simply say I want to show an image, and this would be the standard sort of image source equals /images/foo.jpg in a traditional way. But that last one shows a marriage between the Smalltalk framework and the web framework. I can take a form, which is a simple bitmap display of something, and I can say I want an image appearing in my output, and it's going to be derived from this form. And the Seaside framework automatically takes care of converting that and locating that at a temporary URL that the browser will then come back and fetch. You don't know how hard this is in other web frameworks if you've only used Seaside, and it's a really nice thing that it does that for me. I can do dynamically generated images, and the Seaside framework takes care of all of this work behind the scenes to generate the image and URL and everything for us. This is very nice, very good stuff. Again, mostly unique to what I see in Seaside. The other thing is that I'm typing nice ordinary text there with nice human readable words. Behind the scenes, of course, we're going to be generating things like h3/h3 or image source equals the URL properly escaped and so on. But by using the framework, I'm generating sane HTML, and it's a complete implementation. Everything that's in the standard HTML3 spec is available there, including some of the extensions. So again, because the templating language is Smalltalk, I don't have to shift to a different code editor, a different style of interaction. I can also use the Smalltalk tools to refactor and extend. For example, if I find myself typing the same 5 things in as part of my display output, I can refactor that into a smarter brush or maybe a different sequence of things somewhere in my application. So I can use the traditional tools to extend and refactor the existing code. So Smalltalk being used in templating language is also a big advantage here. We also get multiple vendor choice. For the most part, Seaside applications that you write are actually portable to today 4 implementations, soon to be 5 implementations of Smalltalk. There are a couple of open source implementations of Smalltalk that are worth noting. The one I'm most familiar with is Squeak. Squeak's been around all the way back to the original start of Smalltalk. It has a history going all the way back to when Alan and Dan and those guys were creating it back at Xerox PARC. And that's out there, very nice. Cross-platform, do your development. I do my development on my Mac, and I upload it to my OpenBSD box and just take the same image across and just go straight up there. Don't have to make anything different with it. But there's another player that's up and coming, sort of stalled for a while, but it's back in play again. It's GNU Smalltalk. Complete independent implementation under the GNU license. And it's file-based. If you don't like image development, you can go file-based development with GNU Smalltalk instead. And Seaside works just fine there too. So you can develop in one and port it to the other, depending on your needs. There's also a few commercial players in this arena as well. So we also have, of course, Cincom VisualWorks, which I moved up above Gemstones because James is sitting in the room. Okay. Monty's probably in here too, so all right, but you're in the back. That's it. So he's closer, so we'll do him first. All right. Oh, there we go. It's alphabetical. I like that. There we go. That'll work. So we've got Cincom VisualWorks, very committed to Smalltalk, very committed to Seaside. Been around for a long time. Definitely good implementation there. Gemstone, also again, been around for a really long time. Very committed to Seaside at this point, really trying to get it to work. So again, you can take your application and develop under one, move it to another. It's some sort of Seaside sort of agnostic to all that. So as your needs change, or maybe your development strategies change, you've got multiple implementations. And then I hear Instantiations is also working on Seaside soon, I guess is the phrase. Anybody in here to say when soon means? Everybody's going to admit to it? Fourth quarter. Fourth quarter of any particular year? Okay, that's good. Fourth quarter of a what count? That's good. Well, that's good. So great. Thank you. All right. So again, by having multiple vendors, it means that we can scale our solution or change our design goals, whatever, and not have to worry about going for that. Again, this is mostly addressed to people that are used to dealing with Perl or Ruby. Well, Ruby has another option, but being able to have multiple vendors is actually a great asset there. For team development, Squeak has Monticello. Monticello, depends on what side of the board you're across, right? I'd say Monticello. But it's great because it's a distributed development environment similar to, say, Git or Bazaar or HG. We were able to have multiple people work on the project separately, branch and then merge it back. We have Smalltalk Aware merge tools. So very nice stuff. You're not just doing text-based merging, you've actually got some smarts in there. And if we use Monticello and Squeak, Gemstone knows how to read Monticello bundles, so I can load those directly in if I'm porting from Squeak or developing a Squeak and want to deploy on Gemstone. I gotta say still, Cincom has Store, but I haven't used it much except for load a single bundle, so I'm not real smart about that yet, but that's apparently a distributed development environment. That's the most I can say about that. I'm honest about that. And you can use Smalltalk to use as files, so you can use your traditional development things. You can use Git or SVN or Mercurial or whatever you want to do with that to do your development for new Smalltalk. So you can do good, proper team development with all this. So again, we see that there's a continuous list of interesting things about Seaside that are really leverage over everything else that's out there. Continuations, second major bullet. Okay? What this means is that the control flow in my application, I can actually view it as being uninterrupted between the hits back to the user. I'll go into more detail on that in a minute. It also means that when I define the what happens when a hit comes back, I can actually define that as Smalltalk blocks, Smalltalk pieces of code. It also means that I can actually capture the exceptions in a way that allows me to replay them even later, so that I can go back when a web hit takes a bad hit and go out and figure out exactly what actually happened there. Gemstone has this most development, you can do it pretty much anywhere. So let's look at the control flow issue. So one of the big things about Seaside is that it maintains the inter-head state transparently. So I don't have to think about where I am in my application. In fact, in my application, I would write this like the web isn't even involved. I would have my master object simply say, show the first page, then show the second page until it validates, and then show the third page. And between showing the first page and then coming back, Seaside sort of puts a little bookmark there and says, when we come back, we're going to come back right after that step in the method, so that we don't have to figure out what session we're in, what state we're in, all that stuff. It's all transparently going to bring me right back to the very same line of code that sent the page back to the user. So I can do that sort of thing. The execution state is persisted, including all the local variables. So for example, if this was in a loop that was counting 1 to 10 in a local variable, I would show a page for page 5. I would come back, the local variable with the 5 in it would still have the number 5 in it, so I could increment that to 6 and then show page 6. And again, this is something that is pretty rare in other environments. I know there's some work on Perl and some work in Ruby to do stuff like this, but I think Seaside's got it more maturely developed all the way down. Also, with this sort of thing, we solve the back button issue, because if we can persist a state from one hit to the next, we can also persist it around for a while so that we can come back to it later when we have the same URL invoked by hitting the back button a few times. So again, we can reactivate the precise state of an actual hit. And this is really a nice thing to do. Another thing that this means is that I can abstract not only the presentation layer of how it's laid out on the screen in terms of components and subcomponents, but I can also abstract the idea of a control flow. For example, if I'm always having to log in before I show a certain page to somebody, I can put that control flow and write it once and use it over and over again in my application. Or maybe validate a form using these validation parameters and then continue on once that validates and re-show it as long as it doesn't. I can abstract that out and write that once and reuse it many times in my code. So you get an orthogonal amount of reuse. You get reuse along the visual presentation layer, and you also get a reuse along the control flow layer. And this is possible because of continuations. Also with continuations and the maintenance of state automatically for us, we get callbacks relatively for free. So for example, if I want to say href and make the href do something, I simply tell Seaside, give me an anchor, that's an A, and put exit as the text. But when somebody selects the link, I want it to call the exit method against my current object. I simply put that inside a block of code and say, this is what you do when you come back. Smalltalk Seaside takes care of automatically generating the unique URL that will point at that piece of code and maintaining all the state of my object, the self object, so that it can actually have the exit method called against it when the call comes back. Again, transparent to me, I don't have to worry about it. Smalltalk takes care of that. Seaside takes care of that. Similarly with form elements, I can simply say I want a text input field, and when it comes back, I want to store the value here. I put the code right along where I'm defining it. With this particular feature, I don't have to ever figure out the name of a param again. And I've been doing web dev in Perl for about 15 years. I can't tell you how many times I've created a form that's had name, address, city, state, zip. Okay, and then my boss comes along after that's deployed and say, oh, we need both home and work address. So I copy that to the second part, and I change name to name to, address to address to. Anybody here it sounds a little familiar with, right? Okay, I get a few nods out there, right? Okay, this is transparent. I simply write, I want a text input field, I want another text input field, I want another text input field, and Seaside's taking care of naming all the params for me. Again, the reason I'm going through these points is because I'm showing the differences between other web frameworks and why Seaside really does it correctly. I think this particular feature is probably in some other web frameworks, but I really like that it's all put together in one of them. So my naming, again, of all my hrefs, all my params are automatic. Again, in the area of exceptions, people write code that breaks. Imagine that, even in Seaside, right? So it's great because these exception objects can also be tracked. It takes a little bit of work in sort of the off-the-shelf frameworks, but Gemstone already has a bit of a head start on that. They write these exception things down to a object log. Now this also is saving the entire state of everything that it took to trigger this particular error, all the way back up to the very top level where the error happened. So the error contains some link that activates the exception. I actually changed these slides a few minutes ago while I was watching Dale show this, so it was pretty good. Thanks, Dale. The error includes a link that activates that exception, which means I can use my traditional debugging things, even for an exception that maybe happened last night. So all I have to do is have this enabled, I set this going, and then whenever error comes in, I can come in the morning and figure out what my errors were, go back and debug and fix the code and proceed, and everything still works. So again, by having this sort of framework where I can reactivate the state based on a given exception object or given top-level object, I'm able to do this kind of debugging and really capture the error rather than just trying to debug it from looking at a textually printed log of where the particular states might have gotten to. In the area of persistence, there are a number of options. I'm going to be brief in this section because I'm going to actually go into more details in the second part of the talk. We have traditional object relational mapper routines. We also have saving as objects. So in the ORM space, the traditional object relational space, we have the ORM mapper. It's open source. It connects to Postgres, my favorite database, and others. Well, unless it's an object database. My favorite relational database. There we go. Sorry. Yes. It defaults to a kind of a nice easy mapping, one row is one object, but it's also pretty powerful to map many objects or many rows to a single object or a single row. Well, we got the map there. Anyway, so I didn't do the mapping, multi-mapping. And Cincom's doing some pretty good work there. They're making a thing called Active Record, sitting on top of that. It's still called Active Record, right? Okay, great. I should be editing the talk, but that's okay. You guys are on here, it's fine. Okay, so Cincom's Active Record, which then builds normal blorp records, but requires a bit of a concession in the schema. But if you have a one rows, one object sort of design, you can actually work pretty well with that sort of thing as well. So if you have a traditional database, a traditional relational database, or you're sharing your data with other applications besides Seaside that aren't written in Smalltalk, you can still access those particular relational databases. But if you're staying completely within the Smalltalk arena, there's a number of solutions as well. You can use reference streams, which basically says, starting from the top of a tree, write this tree as a serialized value. Again, more details in the second half of the talk. You can also use Magma, which is sort of a watch this tree and save it as I change it. So therefore, we've got access to sort of an entire tree, and I don't have to go through explicitly and make sure what I'm going to do. One of the nice things about Magma, though, is it can also cluster to multiple servers. So that means I can have many images all talking to the same database and share objects back and forth in a fairly optimal way. Of course, not as easy as, say, I'm spending a little bit of money going off the Gemstone, right, and saying I want one of those instead. It's a very mature, large-scale, persistent VM. Let's see if I get any of this buzzwords the same as their promotional material, all right? Everything being distributed, everything failover, so we have a real solid database that will scale to very, very large applications as well. And again, it's saving everything as objects, avoiding the object relational bottleneck. So again, more pluses for the way Seaside works because we have these options available to us instead of something like Ruby on Rails where you're kind of stuck with all the worms, which add a bit of overhead to your application. Again, talking about things in the Seaside thing, there's a very large community. I don't mean individual people's sizes. Okay, well, I've seen some food table over there. So anyway, so I mean in numbers, not a bad community, right? Okay, not size. You never know. So we have active development. Seaside 2.9 is in beta, so it's not just one guy in a garage somewhere anymore. great team of people working on that. There's also a lot of bolt-ons on top of that. For example, the Scriptaculous library that some of you are familiar with sits on top of Seaside. Nice, tight interaction with that. I'm working on UE, although I haven't gotten much done with it. Other Ajax libraries like MooTools and jQuery and a few others are sitting on top of that already. So we have lots of stuff for the Web 2.0 look. We can get dynamic pages, get dynamic updates, all integrated fairly tightly with the Seaside environment. We also have tools back on the other side. We can manage metadata with Magritte, whatever it's called, and manage the SAT side of the thing, so we can automatically build forms and validate data directly based on the meta descriptions of our objects. And on top of that, we've got things like Peer, a content management system that's been used in a number of applications already. Seaside also has a fairly active mailing list, probably about 30 posts a day there now, maybe 20, 30, something like that, and a fairly good website, seaside.st. And also, just to kind of check things out, if you want to upload a Seaside image just to test it out and share it with your friends, I wouldn't recommend implementing Twitter and uploading it to that. You probably heard that poor little website. Seasidehosting.st, you just have to register for free, and then you can upload your own projects there. So you have a great hosting solution if you want to move things in there. So that is the end of that talk. I put a couple of URLs up there at the end, and I leave that up, and I take questions about that point. But I'll tell you, the response I've been getting from this little talk and a few earlier versions of it is great interest. I would say this talk is under the Creative Commons. Feel free to download it from my website, which is the bottom URL there. Feel free to download that and share it with your friends. If you want the sort of text of this, you can listen to the podcast or whatever the sounds are being recorded from this. But I would encourage you to share talks like this with your friends. One of the areas that's sort of an interesting area, if you're even a halfway decent presenter, you should be looking for these things called bar camps that are happening all over the U.S., actually all around the world. A bar camp is a place where everybody gets together and everybody is automatically a speaker, and it's free. So you sign up. I went to my first one about a month and a half ago. And what's great is these bar camps tend to attract a lot of Ruby programmers. A lot, because it's all about leading edge stuff, just getting in there and networking with other people, building the next cool application like Twitter or something. But if we could start getting Seaside presentations at every single one of these bar camps, it would really spread the word quickly. So look for the ones in your area. If you go to barcamp.pbwiki.com, you can find the locations of the upcoming ones in your area. I think there's something like 25 of them listed between now and the end of the year, so check that out, please. And use these slides or some derivation of it. I'd really appreciate it if you use some of that. And like I said, I had great success presenting this at Fisley, and I've been just going around every place I possibly can, showing these same number of slides there. So that's sort of the first little presentation. Thank you. So that's just what I've been managed to cobble together since the beginning of the year. So now we'll see what I cobbled together in the last 7 days. Okay, a little bit faster here. So this is really the talk that I pitched when I first said I was going to come here. And all I pitched was the title, and then I wrote most of the material in the last 7 days. So let's see how far I got. Okay, first I want to start with a disclaimer, and that is that I only recently re-entered the Smalltalk world. In fact, my first Smalltalk for hire was last month, but I actually now have on my credits a deployed Seaside application after all these years of, well, let me see, I think I first executed a do it in 1981. And so that would be, what, 26 years from my first do it and my first paycheck? Okay, so maybe a record. We'll see. Okay. But I will say that I have been doing a lot of Seaside advocacy. You know, obviously I've been showing this talk or things similar to it, or being online, publishing notes in my blog, and trying to get Seaside being well known throughout the community. Unfortunately, it doesn't pay as well. So being an advocate, as the evangelists in here know, is almost a thankless job, but it works. Okay, so, and also another disclaimer is that I'm talking about persistency for Seaside, but again, most of my experience is with Squeak, so it's going to be a Squeak biased talk. So unfortunately, if that's not your platform of choice, a lot of this stuff will still apply, but there may be variations that might help a little bit better. Now, before I get into talking through basically the survey of the various persistent solutions I found in their current state of affairs, I want to talk a little bit about what makes a difference between one persistent solution and another. And one of the things that gets there is licensing. I wanted to start with a slide on that because it's been called to my attention that I must apparently have something against the GPL or the LGPL. And I want to start out by saying I have absolutely nothing against the GPL and the LGPL. If you're an author and that's the way you want to distribute your code, that's totally fine with me. However, you should understand that if you choose the GPL or the LGPL and somebody else wants to use it in an application that they don't want to adhere to the principles of the LGPL, that may be a problem. That may mean that they don't get to use your code at all. Because using the LGPL code, even the LGPL code, is likely to taint anybody else's code that's in the same image. And the reason is that, from the reasons I'm seeing anyway, from people that have looked at this fairly closely, is that subclassing would be considered derivative work. So even though you have to use the interface provided by the rest of the LGPL framework, and in order to do that, you've got a subclass to do that, someone's going to call that derived. And the people that are, obviously this hasn't been tested in court yet, but let me tell you, you don't want to argue with the FSF on this one, okay? It's a bad deal, yes?
Yeah, I'd actually just like to point out that the dwarf, which is under LGPL, there is actually some specific language attached to the license, sort of trying to explain how we think that the LGPL's rather vague and C-specific language actually means in Smalltalk, and that we don't think that those kind of things would or should happen. So hopefully that at least isolates that particular usage.
You would think so, but I don't want to get into court with the FSF.
Well, but the other thing is the FSF doesn't own the copyright.
That's true. That might help.
So you have to get the perfect E.
Okay. We'll see. We can arm wrestle instead. We'll see. Yeah. Anyway, but as you can see, there's a bit of an issue here because since it hasn't really been tested in court yet, you want to be the first guys to go up doing that, and you've already deployed your $1 million application. So watch out for this. I do also want to say that it's a non-issue for web services. If all you're doing is setting up a Seaside site and you have customers coming in as webhits, this is a non-issue. You're not distributing the code. You're only using it as an API. So this only really applies if you're distributing the code. If you want to build some application and you want to then turn the code out and let other people build on it or whatever, you're going to have to watch out for the fact that the LGPL may mean that everything's all the way across. Again, like I said. So if you're an author, at least consider friendly licenses or at least a dual license. I've got to say that since my experience is in the Perl world, and if that's any experience at all, it's a lot of experience actually. One of the things that having Perl under a dual license meant is that I could go into a large organization and say, I'm going to write some code for you. I'd like to take about half of the code that I write and contribute it back to the CPAN, the shared area that all the Perl hackers use. And the reason for that is that I'm not writing all the code that you're going to be using for the application I'm giving you. I'm going to be borrowing a lot of stuff from the CPAN. So it's sort of like a community potluck. If I take a bunch of stuff from the CPAN, it's kind of be nice if I could give a little bit of it back as a token retribution. But here's the point. I want to go ahead and leave the parts that are most specific to your application, so your competitive advantage. I'll leave that private with you. And by having Perl under a friendly license, a dual license, actually it's the Perl's artistic license, I can get away with stuff like that. So it's nice that way. Like I said, I won't spend a lot of time on this, but I just wanted to bring that up and also tell people I'm not against the GPL, the LGPL. I just think it trades one set of options for another. So why do you need persistence? Why do we care about having data that's around tomorrow? Okay, well maybe you got just a little dumb website where you just go in and enter a couple numbers and show the result. Maybe you don't need persistence for that at all. But in Smalltalk, we all know that objects are living in the live image, in the living process that's actually interacting with the users through the web information. But the image lives only while it's alive, and it only lives on one machine. So you have this process running here, and it's got these objects that are being created as a result of the webhead, but it's really only just there. It's not anywhere else. What you'd like, perhaps, is for you the data that gets created in a particular session to survive past a reboot. Because, that will happen from time to time in your machine, on Windows more often than others, but, no, sorry. Anyway, but, I'm not sorry, I just don't use Windows. Okay, so you want the data to survive past a reboot. You want the data to be there tomorrow that got created today. I mean, your customers would be pretty upset if they came in and they ordered a bunch of items from your e-commerce site, and then because your system rebooted but you didn't get the printout made quick enough or the mail sent off quick enough, you lose all that data. That would not be good. So you want data to survive past a reboot. You might also be at the place where having just one single Smalltalk process isn't enough to serve your customers. So you want to be able to share data with other live images. So we need to think about how to get data from one image to another in as transparent a way as we can. Another reason you might want to look at various persistence solutions is you may want to share your data with non-Smalltalk processes. For example, you could have a bunch of other code that's written in other languages that are all talking, say, to a relational database, or just simply want to get data in and out from your particular Smalltalk process. So all of these have different needs, different sorts of things, but they all sort of relate to the same issue of what persistence is. Now, as we look at persistence, we have to look at another term called reachability. And that's the fact that objects rarely stand alone. I mean, things like small integers that don't have any contents, or maybe an object that only has just small integers as contents, that's probably okay. That's probably like a standalone object. But generally, objects are going to contain other interesting objects. So, for example, a shopping cart might contain a list of items being purchased. And those items would also have like the quantity and maybe the color and whatever. So all these objects are going to have attributes all the way down. The line order item containing the actual reference to the catalog item. Okay? So these objects also in turn contain others. Now, so as we're looking at various persistence solutions, we have to see how they solve the reachability issue. How do we get to all the items that persist, and how do we store that in a way that actually makes sense? There also might even be circular references. So, for example, a shopping cart may contain references to all the items within it, but each of those items may need to know for some reason what shopping cart they're in to be able to add themselves from it or whatever. So there might be circular references, and any sort of persistent solution that we come up with has to deal with these issues of reachability. And some do it better than others. Some is more explicit, some is sort of implicit. So as I describe each of the persistent solutions, I'm going to make some references to reachability and how it relates to each one of those. Another issue, because we never stop developing, I mean, when is it ever really deployed, right, is the fact that we're going to be changing classes throughout development. So, I mean, what do we do to classes? We're making stuff better. We're going to be adding methods. You know, that certainly won't hurt too much for the old objects that already exist. They just simply get a little bit smarter. You should have a little meter of like individual object IQ. That'd be kind of cool. Anyway, so these objects get smarter. They know how to do more things to themselves, right? We might also be adding instance variables. Now, what do you do with that? I mean, maybe you just created in the old objects, adding a nil to them, but you might want to have a pre-initialized value for those, because maybe it's something that where nil wouldn't make any sense. And even more dangerous, we might even change instance variables. Now we have to figure out how to map all these old objects into the new objects in our persistent solution. So we have to deal with that. And of course, something radical like renaming classes is really going to mess things up. We have to simply figure out how to manage all that as well. So if we have persistent objects, we have objects that are out in storage somewhere, we have to figure out what our migration strategy is going to be. Do we just simply ignore all the old ones and tell everybody to re-register for our website? Or do we take them along somehow? And how do the various persistent solutions deal with that? So as I'm talking about each one, I'll mention how migration works for each one of those, for the ones that I'm aware of. So some persistent schemes deal with this, other ones just simply ignore them. Another issue related to persistence is that we have to deal with dirty objects. And I don't mean like, X-rated or something. What I mean is objects that have changed since we brought them back in from storage. How do we handle those updates? How do we remember that we've updated something? How much explicit or implicit work is there to do that? Because we're going to load the object, we're going to make some changes, like say we're loading a customer record and now we're updating his address, city, and state because he's moved. How do we note that in the persistence solution so that it's automatically or manually written down and we're only perhaps updating the parts that we need? And as we'll see, some systems are going to require notification. We have to explicitly tell the persistent system, yes, we've changed this object now. It will require rewriting. And other systems notice automatically. And for some, it's not relevant at all because we're doing all of the writing explicitly ourselves anyway. The persistent solution doesn't really deal with that at all. That would be used in all the same as explicit. And we want to have some sort of system that relates to the persistent solution because we have to write down at least write down the parts that have changed. And so for some of the systems, they actually flush only the parts that have changed. But again, we've got to figure out how to coordinate that with the persistent solution. And various solutions to persistence involve a number of sort of top-level strategies. So in the broad sweep, we've got 4 or 5 major categories here. For one, we can just simply save the image. That's going to be the easiest to do and has the most troublesome about some of the issues, but we'll get to that when we talk about it specifically. I'm going to show various solutions that serialize the objects. In other words, given an existing object tree, how do we write them down to a disk file or store them over a network connection? We can also serialize our data by going directly to a database. So I'll talk about a couple of solutions in that area. We're also going to look at various object relational mappers and some of the things that are in that area as well. And then finally, we'll talk about persisting the entire image rather than saving it explicitly. There's only one player in that area and they know who they are. Okay. So let's talk about saving the image. That's the first category of being able to persist stuff between hits. Periodically, we create a snapshot. We go through the same process we use to shut down an image and bring it back up. We just do it programmatically inside. And I have very little code in here, so if you can't read the code, that's not too bad actually. You probably see most of that. But this is just some simple code that I cribbed off of a web post. Was it Ramon's web post? I saw that? Anyway, I saw it somewhere. Sorry I don't have the credit in there for that. Very simple little persistent solution though. I know this came from the Swiki for a Squeak. Basically, we just say every 5 minutes at a low priority, so theoretically when there's not web hits actually coming in and changing values out from under us, we simply tell the current image to save itself. And that will cause it to snapshot itself and then continue. So it goes through all the shutdown processing and all the startup processing. So it's not trivially fast. It's, I think, in the order of 2 or 3 seconds for a Squeak. That's the last time I looked at it. So it's not a fast thing to do. So during that period of time, the operating system will be queuing up new requests on the socket, but we're not processing anything in terms of web hits coming in. So that's why it's a cheap little solution, simple, you know. But the one thing I also want to caution is that it's saving the same image over and over again in the same address. Excuse me. So one of the things I have to watch out for is that it could be saving an image that I might not be able to restart, or something that's already gone bad because of bad code. So one solution around this, for example, is that we can add a little bit more code that I haven't shown here to actually create a timestamped image. So we can say we're saving it at 4 o'clock, 4:05, 4:10, 4:15. That way, at least if I could come in at 6 o'clock and everything's broken, I can at least try some of the previous images to see where the break was and try to restore it with as much possible data in place as I can. Now, of course, if my system reboots between one of these 5-minute snapshots, I lose that 5-minute window of data. So there's some limitations to this process. Now, maybe that you're just having a blog. Nobody is going to get that upset if the blog post they just made goes away. Well, there's probably a few people in here that would. But, yeah, anyway. But in general, that's not a critical thing. It's not a life or death thing if you're running just, say, a simple blog server. So to have a snapshot that only shows 5 minutes worth of rollback. So this is actually, I mean, since it's 4 lines of code, this is the sort of thing that anybody can apply initially. This is the sort of thing I could do, for example, on Seaside hosting.st, just to make sure that I had some persistence in whatever application I was deploying there. So, very nice way to do that. Again, very simple, very straightforward, does the job. I've got persistence simply by reloading the image. So let's look at various ways to serialize our application objects. And I'm going to break this into 2 main categories of systems. I'm going to talk about a few systems that are file-based. So in other words, we're talking directly to some local file. We're scribbling data in there and coming back later and restoring that back. That's the thing I like about that is it's really simple. Okay, I can deploy it, not much going on, pretty easy. But I also have a couple of solutions in this space that are server-based. And what that means is that I have to have some server set up somewhere that my image is now going to do a TCP connection to and say, here's the objects I want to serialize, go save them now for me. So there's a couple of solutions in that arena as well. And what's nice about that arena is that I can use that for clustering. So this is back to the point I talked about earlier, where if you have a cluster of things that all want to share the same data, you want a solution where you're serializing the objects into a shared solution that's server-based. So of the file-based ones, the ones that I found pretty much break down into reference streams. Again, this is Squeak-based mostly. Image segments. There's 6. There's Omnibase. And there's Mini-Store. Now there's a few others in this space, but these are the ones that I could find out the most information about. One of the things that concerns me about almost everything I was doing to research this is that the information is real scarce and outdated and all that sort of stuff. So if you're wandering off into this arena, I'd already be a little scared. Okay, here we go. Here's the parts that I can figure out how to get working. Okay, so the first thing I saw was reference streams, and I like that because it's a subclass of data stream and therefore a stream. So we use all our standard stream opening, stream reading, stream writing stuff to do that. But instead of reading individual characters, we're actually reading objects and writing objects. A reference stream knows how to serialize objects, which is a great example from Malone's blog. Stole it right from there. So we create a reference stream on a file named blog. And then we say, take the object, self-all-post, whatever gets returned back from that answer, we're going to put that onto the stream. So whatever object self-all-post returns is going to be saved in a serialized way, including all the object's references. So we now have a consistent chunk of text out there that I can revive and revive that exact same object. So all the objects referenced therein are also saved along from that. Okay? So we'd restore that with, again, fairly similar looking code. Reference stream, old file name, blog. So we'd grab everything up to the end, and that would give us the one object back, and that would return back all posts. So that would be the all post variable there would be the same as the return value from self all post. However, in the meanwhile, we've serialized it and brought it back. Not a lot of code there, not a lot to think about, but it's a great way to just simply say, push this out somewhere so I can come back to it later. Really nice little simple solution there. Okay, so that's sort of the first one, probably the one I'd try as a first try. Then I got into seeing some of the other stuff, and I said, well, you know, Avi Bryant told me about this thing called image sequence. So I went to look at it, and I said, oh, this is kind of cool. It stores part of the live image out on disk. But as I started trying to find documentation on this, examples of its use, I kept hitting dead ends. I kept trying to figure out what this does and how I would use it. And there's a lot of old stuff on the Swiki about it. And so I think it's like it sort of automatically brings it back in, but I'm not really sure. I mean, that's how uncertain I am with this. I know you expected me to be up here and be an authority. Too bad. I'm just telling you what I found out in the short period of time I had to find out about it. So for me, the documentation there is pretty obscure. All I know is that Avi's using this for DabbleDB. So if Avi were here, you could go beat up on him and find out how this thing actually works. So that's the most I can say about that. So I've got people shaking their heads at me. Sorry, this is all I know, okay? Can't tell you what I don't know. I would sort of steer away from that unless you got Avi just down the street. That's probably the right way to deal with that. But the next one I found is sort of interesting, and I'll tell you why this is interesting. The 6. What 6 does is it's XML storage. XML storage. Every object in your image can be turned into an XML set of text and back. Before I go too far about that, let me say what I think about XML. So I got the podium. Here I am. XML. I know people are saying XML is meant to be human readable and writable, but you know, all XML really means is that you can represent a hierarchy of textual sort of things, and hopefully you can have something else that can read that back in. That's about all it means to me. So, you know, the great promises of what XML is going to do for all of us, it's never been delivering for me. But anyway, what 6 basically does is it adds a top-level object method so that any object can be told to say as 6 string. That doesn't turn into a guitar. It just simply changes into a string that's in the shape of a 6 string. All right? I don't even know where 6 comes from. Smalltalk image, XML, or something like that. Anyway, what's great is you can also, if you really are so inclined, you can customize the XML. It has a generic fallback that basically stores all the instance variables and then reverses through that to get all the detailed stuff. Let's show an example. It's probably the easiest way to get through this particular page. Again, very similar to what you're looking at from the previous one. You simply say, give me a new file named blog, and then put all your posts out there. Same exact code. I just cut and pasted it, ran just fine. So that was kind of cool. And read only file name back, and give me the contents, and it comes back as all the posts. So in other words, my entire, from the top level on down, of where posts and all everything that it references are going to be stored out in a nice XML form. Well, did I say nice and XML together? Going to be stored out in an XML format that, you know, I was actually able to pick out objects in there, only because like some of the names of things aren't all that obscure, but really I would consider this an opaque format. However, you know, if I was so inclined, I might actually write a Perl parser that could go through and actually pick the objects up on the other side and be able to transfer stuff between Perl and 6. But that's only because I'm really, really good at Perl. Okay, I wouldn't try it in some other languages necessarily. Now, one of the things that I thought was sort of obscure is that I first just cut and paste the code, figuring it all worked just fine. But it turns out that 6 read stream and 6 write stream don't inherit from the stream hierarchy. They inherit from object. and they have a few selected methods that work, and that's it. So you really have to look carefully at the documentation to figure out what methods are actually available to you. So I wanted to put that in as a caveat on this thing. That for some reason, whoever wrote 6 didn't decide to inherit from read stream and write stream what the reference stream people did. So I don't know why. There it is. Like I said, I'll be honest with you here. That's my job. Okay. So another thing in the category of having things written out as object streams, as streams, is Omnibase. So this is from what I could determine about it is that it's a portable object database. Now, from what you just hear, I didn't get very far with this either. It claims to have good concurrency support, large collections. I just copied these bullets straight from their webpage. But I tried to load it into a modern Squeak and it wouldn't load. So this appears to be, at least for the purposes of Squeak, abandonware. It's not going to be useful as we go forward. So I'm a little hesitant to even spend any more of my brain power trying to figure out how Omnibase works if it's not going to be maintained in any sort of current thing. But it is kind of cool. I did like the design of it. Any object in English descendants can automatically persist. What I didn't like about it is that every bit of dirty marking had to be explicit. So if you went in and changed an object, you had to also tell Omnibase, yes, this is now a dirty object. You're going to need to rewrite it when I finally commit. So there was no transparency of the dirtiness, which is, again, a reason I brought that up at the beginning of the talk. I wanted to tell you how these things are actually different. But I did like it, and it did seem to support multi-transactions, transactions where you had multi-variable reading and writing, which is really nice. So like I said, if this ever became a little bit better supported again, if it got picked up again, it might be something that would be worth looking at. But since I couldn't load it into Squeak 3.9 or 3.10, you know, I tried 3.8 and I was able to load it, but I couldn't get part of it to run. So I don't know, just not. And again, obscure documentation. I always love that. That's always the best part. Let me see. How much reverse engineering do you need to do before you can start your day? You know, that's any reverse engineering is okay. A little bit of reverse engineering is okay. A lot of reverse engineering, not so good. Okay. So a mini store. Let's see. This one's even worse, okay? Again, I read the descriptions of it, I get excited about it, I go out to the website, I load it from Squeak Map, and it fails, okay? Well, it actually loaded on 3.8. Again, that's 2-year-old Squeak, you know, back 2 years ago. It at least loaded, but when I said, okay, let me just try running the test failed. Again, that doesn't give me much confidence in being able to use it. Maybe the test failed on 3.4, I don't know. But since the test failed on 3.8, and I couldn't, you know, I started staring at the tests. I said, okay, why is this breaking? I was doing some debugging. I just couldn't get it to work. I just didn't have any sense of that. So again, here's what they claim. Okay, it's got a nice source board page there. It says, English-like query language. I actually like that. It sort of was kind of cool. I could go down and drill down through my objects and use a query language to get to it. It said it had these cool multiple indexes. You know, at this point, this is just teasing me, isn't it? You know, here's these things that say it does all this stuff, and I can't get it to run. It's like, I know it's open source. I live in open source. I understand this, but it says it's got these cool transaction commit and rollback, and it's got automatic disk reclamation and stuff. So it's really kind of cool. And no, I can't get it to run. So I'm going to save you the trouble. Don't go there yet. You know, don't go there until somebody fixes it. So stay away from that. So if you're coming, you know. If you're like me, starting this particular project, you know, it's like you're Googling for, you know, give me, you know, persistent solutions and Seaside. It's great. These are the page you're going to run across. I'm telling you, dead ends. Don't go there. So I'll give you the ones you're not supposed to look at, right? What's funny is that in the mini store documentation, they pointed a particular URL, and I went to that URL, and it's a park domain. So that's really out of the picture. Okay, so again. And if the guy that did mini stores here, I'm sorry, you're just not getting it, you know, whatever it is. Like, he's probably not here anymore. That's probably what happened, right? Okay, so that's the file-based solutions, the stuff where you're writing directly down into a file. Let's look at some of the server-based solutions. And again, I want to talk about the fact that there's going to be increased complexity with this, because now you have not only your image to deal with, but you also have to deal with the fact that you've got, you know, something else to talk to over here that has to be launched, configured, maintained, and so on. So increased complexity, but for that complexity, you can now have the possibility of scaling to multiple processes and perhaps even multiple machines. You can run a cluster of servers. I have to say very carefully, don't I? A cluster of servers, right? To create more scaling for your operation. The main players in this arena, I found two major ones. One is Goods, and the other is Magma. So those are the two that I found that I could at least get some documentation on and follow my way through and even attempt to load into my Squeak image, okay? So what I liked about Goods was kind of nice. It's language neutral, which means it's an object-oriented database that purports to be accessible by a number of different languages. In fact, I even found a CPAN module called Pogo, so I could actually transfer data to and from my Smalltalk image from a Perl application. So I like this. This sounds pretty cool. I'm starting to get really interested in this. In fact, I may pick it up and start doing stuff with it later, except when I get down to the bottom bullet here. You'll see why. Okay. It does require configuring a server and essentially building it, and it's in C++, so you know that would be opaque to me. I one time a long time ago I put C++ on my resume, and I don't even remember anything about C++ anymore. Anyway, so that's there. I'm pretty sure it builds. I didn't try it. And again, persistence by reachability. You basically create a goods connection, then you add objects to it, and you make changes, and it notices the changes on its own. So that instead of like the previous couple things, we had to say this is dirty now. This just simply watches for that and does it automatically. Updates automatically get pushed to commit. Of course, a commit can result in an exception, and the objects get updated in conflicting ways. Oh, I don't have a bullet that says this sucks. Okay, so actually I think this works pretty well. I didn't get enough time to really play with it much. I think I tried to build the server and it didn't build in my OS 10 box. So I think that's probably the next step that I was stuck at. I couldn't compile the server. So again, you know, there you go. That's got it's not bad. I think it's fairly well documented. I saw a lot of great examples on the website. You know, it's good. It's getting there. But I didn't get very far with it. So there you go. Another one that's sort of interesting, also in this arena, is Magma. And again, it's a modern object database for local or clustered persistence. So you can use it either in file mode with just a single user, or you can use it with a server, where you actually have a number of images all talking to the same server. It's a very simple transaction protocol. So you basically say, I'm going to do all these things within a transaction, and it keeps transaction boundaries for you. It has ACID fault tolerance, and so on. So it's pretty good, because you all know what ACID is, right? Handles large index collections, or at least claims to. I didn't get a chance to play with anything large. It also claims to have live class migration. So as you're pushing out new objects, the class goes with it, and as you're pulling objects out, it compares the old class definition to the new class definition, and automatically does the appropriate rewriting with the tools that are provided in the behavior class. So very nice stuff for that. That's really cool. The downside is it seems to be a one-man project. I may be wrong, but I've only ever seen stuff by one guy about this. You know, I can see other people using it, but I only see one guy saying, I'm the guy writing it. I can't remember his name right now. Sorry about that. But it seems to be like, and that would concern me. I mean, if there's not a lot of people supporting this and standing behind it, like I said, I could be wrong, but it looks like a one-guy project. It's the only thing that's wrong for that. The other thing that would still also lead me to be a bit wary about Magma, just to be fair about it, because it looks pretty good, actually, but it needs to be brought down for vacuuming, which means that as Magma objects get created in the on-disk storage, things get unused because you've got a new version of it that's now in a different place on the file, so the old lines still stick around, the old storage still sticks around. They have tools that do the vacuuming to actually clean that up and restore it back to the smallest possible file size, but it requires that the Magma database be brought down. In other words, you can't have clients talking to it at the same time. So that means that at this point, Magma would be unsuitable for 24/7 applications. You'd have to figure out a way to have some downtime once in a while to clean up that disk file, or maybe sort of a live write-through and kept, not ready yet, not quite ready for prime time. That's what you're really aiming for on this thing. You have to have some downtime with this, or else infinite disk. Okay, so if not infinite disk, let me know. I've got some things I need to store, but most of us don't have infinite disk, so you're going to have to use vacuuming on Magma from time to time. But Magma's kind of cool. I've actually got some code examples, because I was able to get a bit further with this. So you basically get a session that's going to be either a remote connection via TCP/IP, or it's going to be a local connection to a file. That's only for using single user mode. You can't have a local connection to a file that's also being shared by other people. That's going to suck. Okay, so you would get a session object. You use this session to create changes. You do this by creating a commit block. You take your actions inside that. Within the session, you also grab the session root and use that to update all the reference data. And then at the end of the block, you can commit or roll back. You commit by just letting it fall off the end of the commit block. You roll back by throwing an exception, and that causes the transaction to abort. And what's great again about this is that it's watching the objects you add, and it figures out that there's more new reachable objects. So it's all really transparent. That's one of the things I really like about Magma, the design of it, is basically I'm just going to start looking at my objects. I get them first out of the Magma database. I can do any kind of changes I want to them, add new objects to the tree, and so on. And that's all transparent to me. The rest of the application doesn't have to know that these are really objects that are going to be serialized and stored out in a shared database. So that's really nice. It's like I said, it's looking like a good solution if what you want is that kind of transparency and that kind of clustering and stuff. But again, one-man project, and it can't be 24/7 yet until that vacuuming thing gets taken care of. So I don't know, send him money or something, I guess. Maybe I'm working on it some more. Somebody else whose name also escapes me, I'm not very good with names apparently, which I should have put in here, right? Created this package that actually merges Magma with Seaside. And it's great because it's the Magma Seaside framework package. It's in the Squeak source, and I'm sure there's other versions of that as well. But what it does is it adds an extra WA Magma configuration to the set of classes you can do. So you go into your application in Seaside, you add this as one of the configuration add-ons to your application. And then when you go to configure your application, you get an additional configuration screen. And the resulting configuration screen lets you configure the location of the server, as in, is it a local server, is it a remote server? Is it a remote server? Give you the TCP IP address and so on, or the host name. It also lets you establish whether you want to use a single connection or a shared connection or a pooled connection. So each session normally gets its own connection unless you change that. You can actually use a pooled connection and save yourself some TCP connection and so on. But within your Seaside application, then, you can get at the top-level Magma object by saying self-session, which gets you session object, and then calling Magma on that gets you the Magma object. From there, I can create transactions, access the root of my data that's in the database, and so on. Now, there's also an additional feature of it. You can actually point the Magma root at your application top-level data. So you don't even have to have this root add and @put and stuff like that. It just simply recognizes your top-level domain object as being the top level of everything that should be persisted within Magma. So it's a really nice, transparent solution if you're working with Seaside. So if you're looking for something that scales to a cluster and is transparent to Seaside, this really is sort of the best solution that I found in this arena, with the caveats that, like I said, one-man operation, and it can't be used 24/7 yet until it gets the vacuuming situation completed. So that's that solution there. Okay. We also have various ways to talk to databases. Okay, the ones that I found, again, fairly easily that I tried to load were SQLite, a Postgres one, and something about ODBC. I also found some other ones in some unmentionable databases, and by that I mean that friends don't let friends use MySQL. So, although there is a MySQL interface, I can't, on good ethics, actually recommend using that. And if you can afford a full-time DBA, you can afford Oracle. So if you happen to be stuck with Oracle, fine, but Oracle obviously isn't where your persistence is going to be unless you can afford the full-time DBA. So there are some interfaces for that, but I didn't even get close to those two. So let's look at SQLite. SQLite was pretty cool. It was a wrapper around a fully featured SQLite library. Now, if you haven't seen SQLite before, you should really take a look at it for a persistence solution, even independent of Smalltalk, because SQLite is this amazingly wonderful, sort of almost unsung library that is a full SQL implementation. It even has transactions, triggers, stored procedures, and all sorts of other wonderful stuff. And it's fast, very, very, very fast, because it's only talking to a single file. But it has transactions, commit, rollback, everything. You've got foreign keys. It's got stuff MySQL only added like a couple of years ago, so it's pretty cool. Anyway, and it's also very small, which means applications could actually embed all of SQLite in them. The SQLite Smalltalk wrapper doesn't do that. It uses FFI to talk to the native SQLite live. So that does mean there's an external dependency. So if you deploy this on the Mac, all Macs come with the SQLite library, all modern Macs anyway do. On Linux, you'd have to make sure SQLite was installed, but again, pretty much most installations of Linux already have that installed. On Windows, who knows? But anyway, you have to have SQLite installed, and that's the only external dependency there. Now, sad part, here we go. The right hand giveth, the left hand taketh away. Couldn't load it into Squeaky 3.9 or 3.10. So again, here's a problem where I'm trying to play with it. I'm trying to get to use it, and I'm not even able to put it together. I'm not going to go back to Squeak 3.4 just to try this stuff out, okay? That's so old, it's not going to happen yet.
It does work on VisualWorks, though.
Oh, good, so VisualWorks. So migrate everybody on VisualWorks, and works great. Thank you, thank you. Good.
Cincom will love that.
Excuse me?
Cincom will love that.
Cincom will, I couldn't hear that.
Cincom will love.
Cincom will love everybody. Okay, yes, thank you, right. All right, very good, very good, yes. So, too bad, Squeak people, you're not going to be able to play with SQLite. I'm sure it's just a small matter of programming. And it's actually, I think, a little more related to the fact that the modern Squeaks have a different version of Monticello, and then that's causing problems because of load ordering and some of the libraries there. I don't understand it all yet. All I know is in the time frame I had to research this, couldn't get it to load, and it frustrated me. I'm easily frustrated about stuff like this. But what's great is SQLite, very simple to use. You connect to it, and that provides a TCP/IP connection to the SQLite server that's, oh no, sorry, not TCP, what the hell am I talking about? Okay, it's the, you basically connect to the library, and the library opens up a file based on the name that you give, right? There's no TCP involved here. So you use this connection now to execute SQL. It's a very simple interface though. Basically, you say, here's my SQL, and it runs it, and it returns back an array of dictionaries. So it's a very simple in and out, right? So it's a simple structure, in and out, very easy. However, one of the things I don't like about it, and I think this would actually lead to possible programming errors, is it doesn't deal at all with placeholders. A placeholder in SQL is where you can put a notation that says, I'm going to eventually provide the real value that goes in here, and I want you to escape it properly so there's no chance that somebody can do an SQL injection attack against this data. And since this SQLite library doesn't do that, it means you would have to be a smart person, capital S, capital P, what the first letter person was, that's scary. Okay, you'd have to be a smart person to figure out exactly how to escape the data so that it would actually drop into SQL properly to create the SQL that we pass to SQLite. So in that sense, I'd be a little wary of that. Yeah.
I should mention that along with what Alan said about SQLite working in VisualWorks, when I was giving the Web Velocity demo earlier today, the persistence mechanism for store was using SQLite.
Cool. Cool. That's great. And it's probably using like the exact same libraries, or you guys have a different one that actually works better?
I don't even know, actually.
You don't know? Okay, right. Well, there we go. But anyway, so again, if you want simple persistence, the other thing that's a nice advantage is if you're storing your data and you're doing your own serialization out with SQLite, dropping it into ordinary tables and rows, that means you can come along with other applications written in other languages and access that data, and including concurrently because SQLite has transaction locking. So this would be a great way to sort of have your Smalltalk image be able to save data in a persistent way and interoperate with other applications. Now, if we go up a step in the conceptually here, we've got Postgres, my favorite database. It's conceptually similar to SQLite, but of course a lot more power. The Postgres driver that I was able to play with and download and actually put in production, so I know this one actually works, is also has the nearly complete Postgres protocol. So between a Postgres client and a Postgres server, obviously you have ways of sending SQL over and getting the results back, similar to what we just talked about with SQLite. But we also have the more elaborate protocols of things like placeholders, streaming results, where you could say, I want a query that's going to return a lot more than I can hold in memory. Can you give it to me a little bit at a time? So that stream is enabled by Postgres. You can do that with the Postgres library in Smalltalk. And events. There's an event notification system that allows multiple connections into a Postgres database to sort of let each other know when something happens. So that's all supported by this library as well. So it's really a fairly complete implementation of the fairly powerful Postgres connection protocol. So that's really nice. I mean, obviously, people put a lot of work into this thing. However, it's slightly outdated. Once again, it looks like it hasn't been updated in a couple of years or something, because when I was talking to my 8.2 system, I had to actually monkey patch a part of the code to get it to work. So this scares me once again, because it's slightly outdated, it's not working with it. Now, unfortunately, the monkey patch that I put in there was very specific to my customer's application, so I can't even submit it back upstream because I don't know how general it is. I know it's very specific, just to one extra data type that my customer has that isn't supported in the current protocol. But a real patch should probably be worked out that it supports, there's something like 10 new types that aren't being supported in the protocol. So anyway, so it's outdated, it needs to be patched. There we go. But I like this one. This one actually works. Like I said, I deployed a customer application with it already. Pretty happy about that. Okay, we also have ODBC. I don't know much about that. I know you got Windows guys love this stuff. Just put ditto, create a connection, send SQL, get back data. Okay, haven't played with this at all, so I just wanted to put it there, right? Same as other stuff, right? Let's talk about some of the object relational mappers. There's a couple of categories here. We've got Glorp, which is sort of the primary thing. We've got Cincom's active record built on top of that, and we've got Rub. So we can talk about each of those. Okay, Glorp maps objects to tables. It's a very large package. I tried reading through the entire source code for it once and fell asleep midway through. It's big, lots and lots and lots of classes. Mostly organized. Somewhat weird names that might conflict with other applications. That was the other thing. We're not using namespaces in Squeak. Some of the names in Glorp sort of scared me that I might want that in some other domain object somewhere, so it's too bad. Like most things, mostly underdocumented. But it comes with a large test suite. So most of the education I got about Glorp was going through the test suite. Thank you for writing the large test suite. Okay, that was cool. Postgres seems to be the primary target, but it does. But again, some of it must be outdated because I tried a few things again. I don't know whether it was the Postgres driver or some of the stuff that was in Glorp, but there were certain things that looked like they would be really easy to do, and they didn't work quite right. So something about the automatic probing to figure out what table columns you have and stuff. Some of that doesn't work. Foreign keys are broken, so it doesn't work. Also, tell GPL, again, Alan actually explained that that's not really a big issue, so there we go. Keep moving forward from that. So, this is kind of spooky having Alan in the room. But anyway, can you leave for a second? Anyway, so a Glorp descriptor, well, now you see what I interpreted from the documentation. So a Glorp descriptor system, which is what I would have written had more room on the top of the slide, defines what a table contains on the database side, what the objects that are going to participate in Glorp serialization look like on the other side, and then how to map them in the middle. So there's really three basic pieces to it. And what's great about that is it's a really flexible system, perhaps too flexible. And there's a lot of stuff you got to do to set everything up, just to say, I want this object, which already looks like a row in my table, to go over here. There's a lot of work you have to do to get to that. But what's great, again, tests are there. They provide a variety of examples, wonderful tests. There's lots and lots of examples in there, but you have to read through to get that to happen. So, Glorp mappings. The simple mapping course is one-to-one. You basically describe a table, and if you have the option to do this, you create an object that just looks like a row of the table, and then you simply describe that object, you describe its mapping to the table, and you're done. Pretty easy. But what I like about Glorp, and in fact I haven't seen in the Perl rule for object relational mappers, is that you can do some really interesting complex mappings. Like one of the kinds of mappings that I saw in there that was pretty cool is that based on some part of a row, you could return different kinds of objects. So for example, if you had an employee versus a manager, you could return a manager object when the manager bit was set, and you could return an employee object when the manager bit wasn't set. And so if you have hierarchies of inheritance on the object side, you could then get the mapping to and from them in the database in an appropriate sort of in and out direction. And another mapping that I sort of liked was that multiple rows in the database could combine to result in just one object value over on the object side. So that was pretty cool. It's actually a pretty powerful system. I know a lot's been written on it. Spent a lot of time staring at all that. I deployed the recent application I did for my first paid job with Seaside. Was in fact done with Glorp, so I had to learn a lot about Glorp to do that. And I'm saying it's, once you get your head around it, it's not bad. It's a really nice system. It's just a really hard system to get into to start with, that's all. And it's also, because Glorp is so powerful, it's possible to map existing objects to existing relational databases for the most part. So unlike other schemes where you kind of have to build one based on the other, or you have to restrict the kind of schemas that you have, this one really looks flexible enough to take almost an arbitrary object out here and almost an arbitrary scheme on the other side and figure out ways to map it where it semantically makes sense. Okay? So what it looks like when you're using it is you create a session object, which is made from an accessor object, which is made from a connection object, which is made from a login object. It's like object crazy when you built this. What is this stuff? Anyway, so it actually makes sense when you look at it, but it was just funny because I have in my application now, I have 4 lazily defined instances that all have classes on one side and a default instance, and then instances that lazily create them. Anyway, I just say give me a session, it just does all the work behind the scenes. So anyway, so now you've got a session. That's good. That's the next best part, right? So Within a unit of work, you're going to make changes and use a session to query the existing data. You create new objects and add them, and it notices the new objects. Well, if you create brand new objects, you have to add them yourselves. But if you have, if you attach new things to existing objects, it already notices that. That's kind of cool. So it is doing some trace down, some reachability stuff to figure that out. Then you commit a rollback. So it's actually pretty cool. It's a really powerful, it's a mature system. It works well when it works, I guess, and when you understand it. So it's great. It's great. Sorry, I don't mean to be, I'm trying not to be too offensive at all. I really like it. It's good stuff. Okay, what Cincom did, though, is they said, well, this is a great start. What we need is to be able to make it a little bit easier for people transitioning from things that are using Active Record on the Rails side, for example. So it handles the simple mappings of Flora. If you can build an object that looks exactly like the row of a database table, and you've got that flexibility in your application, then Active Record will do most of the work for you. So it probes the database, but can also create the database. It gives the mappings on the one side. It presumes a few certain naming conventions like the ID and stuff like that, similar to what Rails Active Record does. At least I'm presuming this by looking at the docs, and maybe is that right? So it presumes a few certain naming conventions, right? Yeah. Right. So it's no good for legacy databases. If you don't have complete control over the database that you're trying to hook up to, this might not work. So because of the certain conventions that are required. But I'll tell you, I'm pretty sure that Active Record, if it works the way I expect it to, it's going to handle 80% of basic persistence. And I hear it's going to be open source, although I don't know if that's committed yet. Is it committed?
Should be, yeah.
Should be. All right, good. Yeah, so that's great. Cool. Look at these guys. All right. Thank you, Cincom. All right, row. This was one of the other things I came across, again, as I was looking for good ORMs to map things back and forth. There's the relational algebra evaluator. Why isn't it Ray then? Anyway, whatever, row stands for something, and RAE is what I got out of the letters. Okay, underdocumented, go figure, all right? Obvi's code. How can you not have underdocumented Avi Bryant code? Okay, but at least it has tests. All right, good, I like that, as long as there's tests. So this is a clue to all of you people who don't know how to write documentation, at least write tests. Thank you. All right, there you go. That's my statement. Okay, here's the abandoned. Haven't seen the updates in it in a long time, but at least it talks to Postgres. That's great, so I was able to play with it. And what's nice about it is, I like this aspect of it, it lets you write SQL queries as Smalltalk using a does not understand trapper. So you basically create a sort of a row, and you start sending messages to it within a limited subset of messages, and it builds up the SQL behind the scenes that would be that kind of query. I like it, it's kind of fun, cool stuff. And then it evaluates an expression, pushes it off to the relational database, it actually takes care of things for you. Again, it handles queries, it handles updates. I don't think it's handling inserts. You have to just do raw SQL to do the inserts. I couldn't find anything that does inserts, but maybe I wasn't looking hard enough. So I'm guessing. Again, underdocumented, there you go. Abandoned, underdocumented. That's cool. All right, let's check that out. Now, the last thing, next to last slide. Okay, almost done. Image persistency. So, of course, the easiest way to do persistency is to not do anything about it at all. Okay, have your entire image just persist. There is really only one player in that space that I'm aware of, right? Okay, unless you have competitors since 8 o'clock this morning. Okay, and of course that's Gemstone, and I'm just going to defer that to Chrissy Dale's blog. He's got all that information on how this works with Seaside and great examples out. That's going to be a lot easier than me trying to reproduce. Oh, I know. Or see his talk this morning if you can go back in time. Okay, so maybe you've got that ability. I don't know. It's just a simple method call. Anyway, so more info. Seaside MST. There's a couple of pages in the Squeak wiki that give sort of where I got the notes from originally and where I started doing my research. There's also my blog out there. I've got apparently about 8 minutes for questions. Thank you for the talk back. All right. Any questions of what I just covered, or y'all just stunned? Yeah.
What would you see this the common theme behind this, the incompleteness of so many packages? So that was a pattern in your presentation. Yeah. And is there a link between incompleteness, abandonness, and open source?
Let me give you parallel examples from the Perl community, because that's where I have the most experience about what makes a project work, what makes a project not work. And I'm sure a lot of that applies to this too. There has to be a critical number of users. There has to be sort of a critical mass of users. And also, and the reason I'm putting out the one developer issue on a couple things, there has to be more than one developer. Those seem to both be essential components of any project that's succeeded in the Perl space. In other words, a certain number of people are already using it, so community starts to develop around it. There starts to be like maybe a mailing list or a wiki that's getting updated every couple of weeks or better. There starts to be patches being recorded. There's a place to report a bug. You know, as soon as you start having this community signs around something, it tends to have a consistency and a persistence there. But if you don't get to that level, then a great idea will fade away a year or two later because there's nobody using it at all. And I think that's probably the only way to explain it, is it really just you have to get to the point where it's critical mass. So it has to be sexy enough to solve issues that a lot of people are having. It has to be well designed so people can come in and figure out where they can help with it if they want to make a change to it or they want to extend it for their application. It needs to be better documented. I think part of this underdocumented stuff actually, I mean, look, how many things did I encourage you to use out of the 15 or 16 solutions I gave it? Not a lot, because I kept saying they're underdocumented. Well, how's that going to ever, it's a chicken and egg problem, how's it ever going to help those things? It's not ever going to happen, is it? So it has to be documented, you have to be able to explain how to extend it, and there has to be more than one developer, there has to be a community around it. Once you get to that level, most things that deserve to survive. Does that answer for you?
I wanted to know about opinions.
Oh, you had, okay, great, that's cool. Right, Richard?
You mentioned the good points
Yes.
of the Squeak. When you're talking about Squeak, how you solve, Seaside, how you solve it and how things that really communicate to your audience.
Yes.
Were there any things which were continual objections that you could see the audience were responding to?
Oh, yeah, great
points
question.
which you had to climb a hill to
Yes.
get past their skepticism.
I'll repeat the question for everybody else and also for the recording. When I'm presenting Seaside as your next web framework, are there common questions or common concerns that people have? And most of them are related to the fact that it's Smalltalk. And the number one in that area is that stupid image. How do you deal with the image? And I always say, try it for a week. You'll never go back to Emacs again for editing anything long. It's actually pretty cool. It works nicely. So there's that sort of level thing. Performance, and that's again, so this is ancient stuff that the Smalltalk community still has to sort of unbury themselves from, which is, Smalltalk's really slow, and you have to edit an image. So those are the two big things. It's really Smalltalk related things. They're generally excited by the continuation stuff, the intricate debugging, and that enthusiasm often carries them past the idea that, well, if you get that much value out of it, maybe I will go ahead and try the image, and I tell them it's not slow either. Look at any modern implementation of Smalltalk, and it's pretty decently fast, and only getting faster. Within the Squeak community, we have all these great jitters coming around the corner that are going to be deployed, and that's going to really do some, at least change the performance, may not increase it, at least to change it. So let me quickly think of what else is there. If I start doing this, I'm not going to get hired anywhere because there's no Smalltalk jobs. So that's a big one, right? There we go. Cool. So that's another issue. But mostly the enthusiasm is there. It's really fun to watch people's eyes light up when I'm presenting this as an alternative to what they're doing already. In fact, I was hired to teach a 3-day Perl class for a large, well, it's on my website, Freescale, which is a spin-off of Motorola. They do chip development. And I was down there giving a presentation. They hired me to do a 3-day Perl talk, so I did a Perl class for them. And I said, well, I've got an extra day. Can I come in and present this Seaside thing to you? And they said, sure. So I came in, and about half the people that were in my Perl class also were sat in the Seaside class, and some other people too. And at the end of the talk, they all looked at me and they went, why did we just spend time learning Perl then? So there is that kind of reaction to this. I'm liking it. I was at a Perl conference Monday and Tuesday of this week. And again, people coming up to me say, yeah, we're kind of embedded with Perl now. That's why we're at the conference. But everything you keep saying about Seaside looks interesting. And we're looking at it. We're watching it. In fact, Seaside is so interesting to the Perl community that they created a thing called continuity, which is basically the bottom level of what Seaside does in terms of doing a continuation. So you can actually write a Perl program that comes right back to the middle of a subroutine as a web app now. And if you look at the man page for that, the documentation, it refers to Seaside 5 different places. Because the guy likes Seaside. He says, I like what this is doing, but I want to do it in Perl. So this is definitely having an influence on what's going on out there. I think that's about all I can say to that, actually. Any questions? Yeah, here.
A statement, then a question. You get the questions about whether or not you can find Smalltalk jobs. Well, Mr. Ross and I are putting effort into the jobs database so that you can answer that question.
And thank you for that. And I'm noticing it slowly seems to be upticking. I don't know what's happening, but that's great. But I talk about how this is a year of Smalltalk when I'm talking about my presentation more casually. And I really think that. I really think this is the time when a lot of things are coming together. And I think this is the year that's going to propel it forward, with Seaside being the killer app, and it's going to raise everybody else's awareness of Smalltalk. And MagLab too. Thank you guys for MagLab, because I think it's going to really bring it in as well. So I think we're on our way with that.
And where could you hear about the jobs report?
On Mr. Robertson's blog.
Industry Misinterpretations, the podcast.
Podcast.
Yes, the podcast, right. Subscribe to that, and you'll hear me, my golden voice, every week now doing the Squeak Weekly News. Monty?
Go ahead.
Yeah, if you go to, Monty's saying I didn't actually give Dale's blog's URL, that's fine, because I can't remember it. But if you go to seaside.gemstone.com, it's linked prominently from there. Thank you, Monty, for filling that in. Still?
I still had a question.
Go ahead.
When you present Seaside to some of these other groups, what, if any, questions come up regarding security, and generally how do you answer those questions? Security from a perspective of you've got a paying website and you don't want somebody to bring it down, or you don't want somebody to try and tear it apart.
Okay, so the questions about security, I actually don't get very many questions about security when I'm presenting this, except for the question of, those old session states, can you get problems with denial of service attacks from those? And I say, yeah, and we're looking at it. If anybody has a great short answer to that, come see me out during the break and tell me how you solve denial of service attacks against your Seaside site, because I need to know how that's typically done. And that's typically the only thing. They don't ask anything else about security at all, just denial of service attacks based on the fact that the old transactions have to be run somewhere. Any other questions from the audience about either of the two talks, or anything about me in general, or Oregon, or frequent flyer mile programs, or yeah?
I have a comment here. I want to mention a lot of these older persistent solutions that have been abandoned. I think that's a sort of reflection of the fact that this is really hard.
Yeah, it is hard.
I wrote an object relational map for the first Smalltalk project, and it worked okay, but what I learned from that is don't go there.
Yeah.
Don't do object relational mapping if you can all avoid it. And I think there's a bit of a progression in the topic. I went from the really old simple stuff, and those things were abandoned like 5 years ago. Then there's the object relational and so on was abandoned 3 years ago, and then the object database is like Base and the things that are abandoned 2 years ago or 1 year ago. And,
Yeah.
It's just really hard, and so without trying to be
So I'll summarize that for the audio as programming is hard. But yeah, you're right. That's a very good point. Is that it's funny. We have a similar problem in the Perl community about templating languages. There are about 67 templating languages that have been uploaded to the CBAN. And what happens is everybody thinks, it's not so hard just to put a variable in here, and maybe I'll add an if, and then maybe a while. And once you make it Turing complete, you have all the problems of any programming language that you didn't lay on top of that. And so that's definitely an issue. And I'm out of time, so that's probably one more question, and then we'll stop.
I just would mention, what Paul said is quite true. Law has addressed a great many of those hard things. That's quite large, but it's also, I think, quite successful. So I think we are in a position of having a considerable degree of solution to that hard problem.
Yeah, that's really great, and thank you for all that. It's really been very cool. Well, I'm out of time. I'll be around the rest of the conference. Thank you for your attention. I really appreciate it.